FastMCP 3 implements dynamic component visibility control through server-level transforms that modify the component pipeline between providers and clients. The system uses a pure function pattern where transforms receive component sequences and return filtered results, enabling runtime access control without altering the underlying component definitions. We're about to examine how the visibility transform class works in practice, starting with server initialization and the two equivalent approaches for disabling specific components by name. The code will demonstrate both the convenience method syntax and the explicit transform addition pattern, showing how these operations integrate into the transform pipeline.
From FastMCP, import FastMCP. From FastMCP server transforms, import visibility. MCP equals FastMCP server. Hash using the convenience method, recommended. MCP, disable names equals secret tool. Hash equivalent to. MCP, add transform visibility false, names equals secret tool.
This code demonstrates FastMCP's visibility control system using the visibility transform, a utility pattern for runtime component management. The example shows two equivalent approaches: the convenience method, disable, and the explicit transform addition via add transform. Both achieve the same result by marking the secret tool component as invisible to clients, filtering it out from all queries. The visibility transform operates as a pipeline filter in FastMCP's component flow architecture. When applied at the server level, it modifies the component metadata to control visibility state, with later transforms overriding earlier ones. This design enables dynamic access control without modifying the underlying components, allowing runtime adjustments to feature availability. The pattern is particularly useful for implementing feature flags, access control, or progressive disclosure of capabilities. The trade-off here is between convenience and explicit control. The disable method provides a simpler API for common cases, while add transform offers more flexibility for complex scenarios. Both approaches ultimately add the same visibility false, names equals secret tool, transform to the server's transform chain, demonstrating FastMCP's consistent underlying mechanism for visibility management. Let's break it down.
From FastMCP, import FastMCP.
Imports the FastMCP class from the FastMCP module, which provides the core server functionality for implementing Model Context Protocol (MCP) services. This import alone doesn't create any instances or configure behavior. It simply makes the FastMCP class available for use in the current namespace.
From FastMCP server transforms, import visibility.
Imports the visibility class from the FastMCP server transforms module, which provides functionality for controlling component visibility in the FastMCP server.
MCP equals FastMCP server.
Creates a FastMCP server instance with the identifier server. That will be used in MCP protocol handshakes for client identification. The string parameter serves as a label visible to clients during connection establishment, but doesn't configure any operational behavior.
Hash using the convenience method, recommended. MCP, disable names equals secret tool.
Calls the disable method on the MCP object with a dictionary parameter specifying names equals secret tool. This immediately marks the component with the name secret tool as disabled, causing it to be filtered out from all client queries and preventing it from being called. The operation uses the convenience method approach as recommended by the framework.
MCP, add transform visibility false, names equals secret tool.
Adds a visibility transform to the MCP instance that hides the component named secret tool from client queries. The transform filters out this specific tool when clients request available components, making it invisible in listings while keeping it registered in the system. The false parameter indicates the component should be hidden, and the names dictionary specifies which component to target by name. FastMCP3's visibility control demonstrates a clean separation between convenience and flexibility through its dual API approach. Both disable and add transform ultimately insert the same visibility transform into the server's pipeline, but they cater to different use cases. The convenience method abstracts away the transform details for common scenarios, while the explicit transform addition gives you full control over the pipeline architecture. This design choice reflects FastMCP's core principle. Runtime component management should be both accessible for simple cases and extensible for complex ones. The key insight is that visibility transforms operate as pure functions in the component flow, allowing dynamic access control without mutating the underlying components, a pattern that enables feature flags and access control while maintaining system integrity.
The server knows secret tool by name, but pretends it never existed when asked.